Hi folks, we're going to take a look at number 4 from the December 11th homework. So here they're asking us to determine the zeros, asymptotes, and any holes of these three functions. Okay, now I said asymptotes. What I really meant, hopefully it was clear by the context, actually just meant vertical asymptotes. Okay, so if we look at the first two, we see that we're operating with the same two functions, x plus 1 and 2 to the x minus 1. C is a little different. Okay, so let's start with the first. Okay. So you have the product of two functions, so the zeros are whatever makes either the first expression or the first function 0 or the second function 0. Okay, so here we need either x plus 1 to be 0 or we need 2 to the x minus 1 to be 0, and both pretty easy to solve. So x equals -1 or 2 to the x equals 1, and so x, clearly here we can see that x needs to be equal to 0. Okay. So we shouldn't expect any asymptotes or holes here because both of these functions have domains of all real numbers. So the product of these two functions will also have a domain of all real numbers. So we won't have any vertical asymptotes or holes. So we're done with this one here. So I guess we can say no vertical asymptotes, no holes. Okay, so let's move on to B. Well, here when we have a quotient, we might expect there to be some restrictions. So while these two functions both have domains of all real numbers, we see that -1 is going to make the denominator 0, so not part of the domain. But again, let's start with the zeros. So here y will be equal to 0 if the numerator is equal to 0, okay, which we've already solved. So x equals 0 is going to be an x-intercept. But there's something I really should be checking. Okay, I just need to make sure that this value doesn't make the denominator 0. Okay, so this, is a 0 since x, or I guess 0 plus 1, is not equal to 0. Okay, so I need to show that the denominator is not equal to 0. Otherwise, I'd have a problem. Okay, now let's take a look to see if there's any asymptotes or holes. So I see here that, x plus 1 equals 0 and x is equal to -1. Okay, so this creates the denominator being 0. I just have to check whether the numerator is 0. So 2 to the -1 minus 1. Well, clearly 1/2 minus 1 is not equal to 0. So what does that tell me? When the denominator is 0 and the numerator isn't, I know I have a vertical asymptote at x equals -1. Okay, so again, one of the properties we discovered that as long as the numerator is not equal to 0, if the denominator is, we automatically have a vertical asymptote, okay, at that x value. So here I can already see what my issue is going to be because, when is y equal to 0? Well, when the numerator is equal to 0, as before. Okay, so when x is equal, 2 to the 0 is 1, minus 1, 0. Okay, but, not by, but, okay, the denominator is also equal to 0. Okay, and we know that when we have the scenario 0 over 0, well, we're not quite sure what's going to happen. It might be a vertical asymptote, but it could also be a hole. Okay, problem is there's no algebra we can do. So when we had a rational function, there was some algebra we could try to see if we can reduce that factor that gives me 0 in the denominator, but there's no real algebra we can do. So let's take a look at maybe a graph. Okay, so let's see if a graph helps me out. Okay, so 2 to the x minus 1, so 2 to the x, of course, is just an exponential function. So if I do -1, well, I'm just going to be bringing it down by 1 unit. Okay, and so I know my function is going to look something like this. Okay, now if I draw y equals x, well, y equals x is going to look something like this. And when I look at these two functions, it doesn't look like one approaches 0 necessarily much quicker than the other. Okay, again, this is not the best of graphs, but my sense would be that I'm probably going to have a hole at x equals 0. Okay, so what other options do I have? Again, I can't use graphing technology, but I did say you could use your scientific calculator. So another thing you could do is take some number really close to where, I have my issue. So let's say I let x equal, 0.0001, something very close to 0. Okay. So if I input that, y, 2 to the 0.0001 minus 1 over 0.0001, let's see, is this going to be close to some fixed number, or is it going to be something that's approaching positive or negative infinity? So let's put that in. So 2, actually let's put it all in 1. So 2 to the exponent of 0.0001 minus 1. Okay, divided by 0.0001. You got to make sure you get your x values consistent here. And I see that this is approximately equal to 0.693. Okay, so this is not some huge number, nor is it some very small negative number. So my conjecture here is that there's a hole at x equals 0. Okay, and in fact, if you were to graph this function on Desmos, you would see that there is indeed a hole at x equals 0. But again, it's not that I know for sure based on my analysis, but this is, fairly good evidence that I would have a hole at x equals 0.